Hey, so today we're talking about 5.1, which is proving some more identities. Now, we talked about some very basic identities back in either Chapter 2 or Chapter 3, but we're going to kind of dive a little deeper in. So the first thing we need to review is that cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Remember, those are my reciprocal identities. We also need to recognize tangent. We also need to recognize tangent as my cosine over sine. And then lastly, especially this top one, the Pythagorean identity, which was sine squared plus cosine squared equals 1. Those are going to be my basic identities for this section that we need to recognize right off the bat. So let's start out pretty simple. We need to prove that sine theta cotangent theta is equal to cosine theta. Remember, when we're proving identities, we draw a line down and we cannot touch this right-hand side. We can only mess with the left. Well, using my reciprocal identity, let's write cotangent as cosine over sine. Now remember, since we're multiplying, my sines cancel, and we're left with cosine theta, which is exactly my right-hand side. Put a smiley face, a box, whatever you want to do, just to tell yourself, hey, I'm done. So for this second one, remember, draw your line down. I can't touch cosecant. And you may be able to recognize cosecant as 1 over sine theta. So you may be wanting to make the left-hand side look like 1 over sine theta, but I still need to finish by writing cosecant. I have to write what's on the right-hand side. So let's start using my reciprocal identities. My cotangent identity, well, secant is 1 over cosine times cotangent is cosine over sine. Well, since I'm multiplying, hey, my cosines cancel. I'm left with 1 over sine theta. Remember, that's what we wanted to prove here, is it make it look like 1 over sine theta, but I still have to write cosecant theta. Smiley face, just to make everybody know that I'm done. So pretty straightforward. Well, this one gets a little bit more complicated. Tangent theta plus cosine equals sine theta times secant theta plus cotangent theta. Now you notice right away that I have these parentheses on the right-hand side. That tells me immediately that whatever is on my left-hand side, I'm going to have to factor something out in order to get these parentheses. So I have two terms right now that are added, but I want to multiply two terms in the very end. So I'm going to need to factor something out. Well, so let's just start rewriting things in terms of sine and cosine. What's tangent theta? Tangent theta is just sine theta divided by cosine theta plus cosine theta. Now you'll notice what I want to end up factoring out is this sine theta. But at the moment, I don't have a sine theta right here. I don't have a sine theta with my cosine theta. So what I'm going to do is I'm going to multiply my cosine theta by sine theta divided by sine theta. I can do that. I'm literally just multiplying by a fancy version of 1. No hand waving, no nothing. I'm just multiplying by sine theta over sine theta. So let's rewrite what I have. I have sine theta divided by cosine theta plus sine theta cosine theta divided by sine theta. So now I have a sine theta in both terms, so I can factor it out. What am I left with on the left? 1 over cosine theta plus, on the right, I'm left with a cosine theta divided by sine theta. Well, how about that? It worked out just like I wanted to. 1 over cosine theta is secant theta plus cosine over sine is cotangent theta. And I'm done. So remember, the key to this one was, hey, I realized that I have these parentheses on the right-hand side, and I don't have them on the left. So I knew I had to factor something out. Ooh, that one looks a little more complex. Don't fret though, this is literally just the opposite. Notice I have my parentheses on the left, and I don't have any parentheses on the right. So I'm just going to have to distribute something into my parentheses. So you can either start by writing secant and cosecant in terms of sine and cosine, or you can just start factoring in and then rewrite them. I'm going to factor in first. So on the first term, I'll have a sine theta, secant theta, plus sine theta, cosecant theta. And just to make room, my line's going to go over here. Let's rewrite secant and cosecant now. So I have sine theta times, well, secant is 1 over cosine, plus sine theta. Cosecant is 1 over sine. How about that? These cancel out. And my sine theta over cosine theta, well, that's just tangent theta. And then I'm left with just a plus 1. That's exactly what I wanted. Smiley face. So remember, the opposite thing happened here. I realized I had parentheses on the left, no parentheses on the right, so I had to not factor something out, I had to distribute something in. Oh, that one looks a little messy. You'll notice you have this cosine to the fourth minus sine to the fourth. Now, for the sake of this class, or at least this chapter, maybe later on we'll change things up, but for this chapter, whenever you have this cosine to the fourth minus sine to the fourth, that's always going to be a difference or a sum of perfect squares. Remember, perfect squares, say if I had x squared minus 9, it's a difference of perfect squares. That factors into x minus 3, x plus 3. Same idea here. I can factor cosine to the fourth minus sine to the fourth as cosine squared theta plus sine squared theta times cosine squared theta plus minus, I already did the plus one, theta minus sine squared theta. And that's still all over cosine squared theta. My line's going to go over here now. And notice back to my Pythagorean identity, this just here is equal to 1. Cosine squared plus sine squared. So that just kind of goes away. It's 1. We just don't even need to write it anymore. Let's rewrite what I have now. Cosine squared theta minus sine squared theta divided by cosine squared theta. Notice I have one fraction. I have one big term now. But on my right-hand side, I have two terms. I have a 1 and a minus tangent squared theta. So I'm going to have to break up the fraction. I'm going to have to write it in terms of two fractions. So for my first fraction, I get cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. I broke up the fraction. I wrote each part of the numerator over the entire denominator. Well, cosine squared theta over cosine squared theta, well, that's just 1. Minus sine squared theta over cosine squared theta. Well, any sine over cosine is going to be tangent, no matter the power. We just got to rewrite the power. So sine squared over cosine squared is just tangent squared theta. And that's exactly what I wanted on the right. So the key to this one was recognizing cosine to the fourth minus sine to the fourth as a difference of perfect squares. Let's try one more. Now you'll notice on the left, like, hey, I got that sine to the fourth minus cosine to the fourth. I'm going to move this up. Come on. Just so I get more room. So what I would do is I would rewrite sine to the fourth minus cosine to the fourth in terms of the difference of perfect squares. So let's do that. On the top, I end up getting, again, sine to the fourth, sine squared, nope, grab my eraser here, sine squared theta plus cosine squared theta times sine squared theta minus, man, I keep on doing that, minus cosine squared theta all over sine squared theta cosine squared. My line's going to go there. Now remember, sine squared theta plus cosine squared theta, that's just 1, using my Pythagorean identity. So let's rewrite what we have. Sine squared theta minus cosine squared theta, all divided by sine squared theta, cosine squared theta. Yeah, notice what we have on the right-hand side. I have two terms, secant squared minus cosecant squared. But right now I have one term. So I need to break apart this fraction again. I need to take each part of the numerator and write it over the whole denominator. So I will have sine squared theta divided by sine squared theta cosine squared theta, the whole denominator, minus cosine squared theta divided by the entire denominator, sine squared cosine squared. Now let's see what simplification happens here. My sine squareds cancel, so on the first one I have 1 divided by cosine squared theta. On the second one, cosine squareds cancel. I have 1 over sine squared. While using my reciprocal identities, 1 over cosine squared is secant squared theta, minus 1 over sine squared theta is cosecant squared theta. And that's exactly what we wanted at the very end. Okay, let's try out another one here. I'm going to move this up so I have some more room. Come on. There we go. Now you'll notice on the left-hand side I have two terms, a tangent and a cotangent. On the right side, I only have one term. So I'm going to have to do the opposite of what we just did. I have to make the entire left side into one fraction. I'm going to have to somehow get common denominators and then combine. Okay, let's try it. Let's write tangent and cotangent in terms of sine and cosine. Tangent is sine divided by cosine, plus cotangent is cosine divided by sine. Now I need to get common denominators here, so I'm going to multiply the left one by sine over sine. And I'm going to multiply the right one by cosine over cosine. Okay, and we'll make my line over here. So what do we have on the left? I'm going to have sine squared divided by sine theta cosine theta, plus the right one I'm going to have cosine squared theta over the same denominator. I can combine it now. So I end up getting sine squared plus cosine squared. Hopefully you recognize that right off the bat as a 1 using my Pythagorean identity. So I have 1 divided by sine theta cosine theta. And you'll notice that 1 over sine theta cosine theta, if we split it into two fractions again and multiply them, I have 1 over sine times 1 over cosine. Now I'm not going to write that intermediate step because hopefully you can just recognize that as secant cosecant. Kind of miswrote cosecant there. And that's what we wanted, secant cosecant. Remember, the key to this one was recognizing, hey, there are two terms on the left. I have to turn them into one term, so I had to multiply to get common denominators. So go ahead and write your summary and any questions you have, and then please take a look at the assignment. Oh, we had one more after the summary. Let's take a look at it. This one will be a fun one, a good ending. Please write your summary, though. I'll take a look at that, but let's do this one together. It's a good one. So again, let's just start writing things. See what happens. The first thing I have off the top of my head is I have two terms on the left and one term on the right, so I'm going to have to write them I'm going to have to write this in terms of one fraction. I'm going to have to write common denominators. So I'm going to multiply the left one by sine over sine. That's the denominator of my second one. So I'm going to write it by sine over sine. This right-hand term here, I'm going to multiply by 1 over cosine, 1 plus cosine over 1 plus cosine. Let's write what I have now. I have sine squared plus, now, I have two binomials multiplied together. Whenever I multiply two binomials together, remember I have to FOIL them. So I'm going to have to FOIL this out. The ones are first, what's the outside? 1 times cosine, so I get a cosine, plus the inners, cosine times 1, so another cosine, plus cosine times cosine, which is cosine squared. And this is all over my common denominator, sine times 1 plus cosine. Now I kind of did 2 steps in one there. Remember what I did is multiplied by the opposite denominator in order to make common denominator, sine times 1 plus cosine. Then I also FOILed this out. I FOILed 1 plus cosine times 1 plus cosine. Make my line here. So let's see what I have here. You'll notice that I have a sine theta, so sine squared theta, plus a cosine squared theta. Now hopefully we don't need to rewrite this in a whole nother step, but you can recognize, hey, I have a Pythagorean identity there. So that turns into 1. Then I also have another plus 1 here. And I have a cosine theta plus a cosine theta, which is 2 cosine theta. That's pretty nifty. Now I'm going to divide by my common denominator, sine theta times 1 plus cosine theta. Now let's take a look at what I want to end up with. I want a 2 cosecant theta. Okay, so somehow I need to get a 2 out of this. Somehow I need to get a cosecant out of that. Remember, cosecant is 1 over sine. Now I can rewrite this. I'm going to run out of room if I don't do this horizontally a little bit. This becomes 2 plus 2 cosine theta over my sine theta times 1 plus cosine theta. Now you notice that the top has a common factor of 2. So I'm going to pull that out. I'm going to factor out a 2. So I have a 2 times, I'm left with a 1 in the first term and a cosine in the second term, all over sine theta times 1 plus cosine theta. Hey, look at that. Things are happening in a good way. Let's use teal here. My 1 plus cosines cancel. And I'm left with 2 over sine theta. Using my reciprocal identity, 1 over sine is very nicely cosecant. So I have a 2 cosecant theta, which is exactly what I wanted to end up with. So we had a little surprise problem at the end there. But remember, the key thought here was, hey, I needed to turn these 2 terms into 1 term, so I had to make common denominators. But then I had to notice, hey, I have a Pythagorean identity here, sine squared plus cosine squared. I reorganized some things, and then I had to factor out a 2 to get from here to here. I had to factor out that 2. When I factored that 2 out, things nicely canceled, and I was left with a 2 cosecant. So go ahead and write your summary. It was on the previous slide, and please take a look at the assignment before tomorrow. Try a couple out, and then we'll see how this goes. Have a great night.